addition and subtraction of vectors. So before we go into this, let's start by saying what vectors are and what scalars are. Scalar quantity are those quantities that has only magnitude and no direction. An example of such, we have mass, energy, temperature, volume, etc. Vector quantities, on the other hand, are those quantities that have both magnitude and direction. Example of such, we have force, weight, magnetic flux, electric field, gravitational field, and so on. Today we are going to be looking at the addition and subtractions of vectors. By now you know that vectors usually are represented with a straight line signifying the magnitude or the size, while the direction is usually denoted with an arrow head. Now, addition of vectors can be done in such a way. There are 4 rules. I'm going to break it down into 4 rules. The first rule is this. In addition of vectors, 2 vectors can be added, and then you have what we call the resultant. And this single vector resultant will have the same effect with each of those vectors that have been added. So rule number 1 you should know. If you have 2 vectors, let's say x and y, in the same direction, if you have 2 vectors, let's say x and y moving in the same direction, if x is equal to 30, let's say 30 Newton, and then y is equal to 40 Newton, the resultant of this vector is going to be the algebraic sum. So it means the resultant, if x and y are in the same direction, it will be what? 30 plus 40. And 30 plus 40 is equal to what? 70 Newton. So it means if we have 2 vectors moving in the same direction, the resultant is simply the algebraic sum. So we have 30 plus 40 is equal to 70 Newton. 2. If x and y are moving in the opposite direction, the direction is opposite this time around. Using this same case study, if x is equal to 30 and y is equal to 40, this time around we are not finding the sum, it's going to be subtraction. The resultant is going to be what? Subtraction, because it's in the opposite direction. So it means that x is moving in this direction and y is moving in this direction. So therefore the resultant is going to be what? R is equal to 40 minus 30. So the resultant will be equal to what? 10 Newton. Chalk. 10 Newton. Then rule number 3. If the 2 vectors are inclined at 90 degrees, if the 2 vectors, that's vector x and y, they are inclined at 90 degrees, if the 2 vectors are inclined at 90 degrees, we use Pythagoras theorem. We use what? Pythagoras theorem. And what is Pythagoras theorem? We have r is equal to r squared is equal to what? X squared plus what? Y squared. So it means, let's say for instance, this is 2 vectors inclined at 90 degrees. If this is y and this is x, and using our same case study, we said our y is 40, our x is what? 30. So we complete this. We complete it, this is what you will have. Sorry, this is what you have. Here is our resultant. This is R. So this is opposite, so it means here is going to be 40. Using Pythagoras theorem, our resultant will be R squared is equal to X is what? 30 squared plus what? 40 squared. So when you solve this, you arrive at your final answer. You find your what? Your resultant. Case 4. This time around, if the two vectors, the angle between these two vectors is less than 90 degrees, if it is less than 90 degrees, in this case, we use what we call parallelogram law of vectors. If the two vectors, the angle between the two vectors, if the angle between the two vectors is less than 90 degrees, we use what? Parallelogram law of vectors. And what is parallelogram law of vectors? This is a parallelogram, for instance, right? A parallelogram. So parallelogram law of vectors states that if the two sides of a parallelogram represented in magnitude and size represent the two vectors, the diagonal drawn from the common point, this is the common point, diagonal drawn from the common point is the what? The resultant. This is what? The resultant. So the formula is this. Parallelogram, we use this formula. R is equal to the square root of what? X squared plus Y squared plus 2xy cos theta. 2xy cos theta. Addition and subtraction of vectors is an interesting topic. By now, you know what vector addition is. In the next class, we are going to be discussing the resolutions of vectors. Thank you.